All right, here we go, a lesson 1-3. We are doing counting items again. This time we're paying attention where order is important. When sometimes things get really complex, we're going to have to use a new idea called permutations or factorials. Now, keep in mind, the fundamental counting principle is fundamental. You can always use it. Okay? It always works. But like I said, sometimes things get tricky and there's a shortcut. So today we're going to be talking about what this shortcut is. You will need a calculator. Okay, do you have a calculator? We're going to use a part of the calculator you haven't been to before. So it's really important that you have access to something like this to do that. Otherwise, you're going to be scrambling. So go get a calculator, pause the video, and then come back. All right, first things first. I'm introducing to you a new symbol. Most calculators have this key on your keypad, and it represents x factorial. Some kids shout x, but it's not. It's just x factorial. And what it means is it's going to take the number x times whatever number you put in for x, times x minus 1, times x minus 2, dot, 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 all the way down to 1. So for example, if we typed in 6, and then we typed in that key, and again, you've got to find it. By the way, most calculators are hiding it under a PRB key on your calculator, all right? 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And it does it in one fell swoop. So you don't have to actually type those numbers in. Now you can type in 6 and 5 and 4 and 3 and 2 and 1, but if you have the key, it's a faster way to get 720. Okay? Try it on your calculator. Let me verify. I didn't check. Is that true? 6 factorial. Yes, 720. All right. Item number 2. Here's where the shortcut, that is a shortcut there, but there's an even better shortcut. And here it is over here. Strongly recommend that you copy this down into your notes, because this isn't something you're going to remember. All right? This is the rule, and it's right here. What does this mean, this rule? I'm not going to explain like too much why it works. Maybe a little bit. But this means if you are taking what we call permutations, another word for permutations is arrangements. Okay? So these two words are synonymous. So if we're looking for arrangements, and remember today we are counting things where order is important, then we're looking for permutations. Now, there's two little subscripts, one in front, one in back. The number in front is how many things are we picking from, and then the number afterwards is how many are we choosing from that list. Your calculator, what we'll do, and I'll show you how to get that on there in just a moment, because that's also on your calculator, it takes n factorial divided by n minus r factorial. Okay? And it computes that and gives you the result. All right? So this is the number of arrangements. Please, again, copy this into your notes. Of n things, of r things out of n things. And again, fancy word for arrangements, permutations. That's why the P is there. All right, first of all, let's just think about when are we going to use it, and then we'll actually use it in an example. All right, let's say you are dialing a phone number. Does order matter? And yeah, it does, because if you dial it out of order, you'll get somebody else. How about ice cream flavors on a cone? Does order matter? Most of us get so excited about ice cream that we just don't care what the flavors order is, just as long as you get the right flavors on the cone, then we're happy. So in this case, the first case we would say yes, order is important. In this case, no. Though there, I'm sure there's some people that say, well, okay, my lemon ice cream's got to go on the bottom because I want to finish with that nice citrusy flavor in my mouth. But we're going to ignore those people who tend to be a little too obsessive. Example 1. Hopefully you are still tracking with me. You're typing in an 8-letter code, password. How many options are there? So you are trying to break into some Swiss bank account. All right, well, the fundamental theorem, counting principle, would say for the first letter, you have 26 choices. And I'm going to say for the sake here that none are repeated. All right, meaning you can't use one letter once you've used it. So 26 times 25, because there's one less, times 24, 23, 22, 21, 20, 19. Multiply those all out, get your answer. Now, for most of us, doing that on a calculator is doable, but there's a good chance we'll type in a mistake because of so many calculations there. Whew. So we have a shortcut. And the shortcut is, I could say, I want, of 26 things, I want to permute 8 of them. So what we're going to do is, first of all, type in 26 factorial. Then in your denominator, you're going to say, what is 26 minus 8? So I'm going to do a little bit of subtraction here and say, ooh, that's 18 factorial. Now, pause, just watch this, don't copy this down. This means 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19, and I'm running out of energy, yeah, all the way down. And then 18 times 17 times 16 times 15 times 14 times 13 times 12, all the way down to 1. All right, if you were to multiply these all out and then divide them, you would then have the result. And you would say, Ms. Larson, that's more work. What do you mean? Well, first of all, notice these numbers here cancel all these numbers here because they're all the same. And when you divide by those same numbers that you're multiplying by on the top, they cancel, giving you 1. All right? Now you'll notice this work here is the exact same as the work that we had up here in our fundamental counting principle. All right? And so, yeah, if you did that by hand, either way, it would be the same work. But if you go to your calculator now and you type in 26, and then you look for a key called NPR. Now, again, the place that you find that key option is typically in PRB. Okay, it's in a menu called probability, and you'll find NPR. Then you type in the 8, and then you hit the equal. I'm going to do that on my calculator right now. So 26, and I go up and grab NPR, and then 8, and I hit enter. I get a crazy number. It says 6.29. Whoa, 6.29. 9. And then some more numbers. And then it says something like E10. And what that means is, this is scientific notation for 6.299 times 10 to the 10th power, which means I'm moving the decimal spot 10 places over. So this number is going to be, I'll write it out over here, 6299. So I've moved it 3 places, and now I'm going to add 7 zeros. And then I'm going to put my commas in. Get rid of those things there. So now I can read off the number as 62,990,000,000. Okay? Ways to crack this code. Quite a few. All right? So, on your calculator, very important, kiddos, find this key. Okay? I'll be doing that in class in Google Meets. I can show you. Come on in and I'll help you find it on yours. Now, the crazy thing is, since we know how this works, yes, we can even do things our calculator can't. So I'm going to try this one on my calculator, and 100 NPR to, some calculators this works, sometimes it doesn't. Let me try another one. 1,000 and 998. Aha. Okay. So some calculators, these numbers that we type in will be too big, and our calculator is going to fail. But we can actually figure it out. And so if I write this out using the rule, 100 factorial over 100 minus 2 factorial. Most of us can do 100 minus 2 in our brain. We get 98. Yeah? And now we know that 98 is a long tail. 100 is a long tail. Well, each of those tails cancel, and the things that are left upstairs is the 100 and the 99. But the 98, factorial, cancels with this 98 factorial. And so they're gone. So all I'm left with is 9900. So there's a way to do these calculations, sometimes really fast, if you know what you're looking for. I want to close up here just with looking at examples, whether they're arrangements or not. It's going to be really important that you decide that. If you're dealing a 5-card hand in a game, is order important? And the order is not important in this case because when you get the hand, you can shuffle those in your hand however you want. Now, some people will say, well, you need to have them in your hand in a particular order, and that's true. But when they're dealt to you, it doesn't matter how you get them, what order. How about a cashier returning change? You go buy something, you pay with a big bill, and she gives you some change back. Does it matter? And most of us will say, no, it's not a big deal how you get your change back as long as you get the right change back. Now again, some people say, well, you got to get the coins first, right? And then the bills afterwards, or the bill first, and then the money afterwards, whatever. I'm not going to get into that, but most of us will say it's not a big deal. What about opening a padlock? Well, when you put the numbers in, if you put them out of order, that's going to be a problem. That is a big deal. A child coloring a rainbow with crayons. Is order important there? The order that they grab the crayons. And for most of us, we're going to say no. It's not a big deal. Kids can color rainbows however they want. Some of you are artists, and you know that there's Roy G. Biv, and rainbows must follow a particular scientific pattern. But remember, the order that they color it in is not a big deal. The fact that they put the colors, which one they put in first, is not essential. Okay? Your homework is on page 9 in your textbook. It's problems 1 to 13. Again, if you struggle with these, come see me, and I can help you solve them. Best of luck.